Hello there, I'm William Bush, the Field CTO here at CloudCasa, and today we're going to be covering backup as a service using Ondat Snapshots with CloudCasa. So there is a quick start guide available that goes alongside this video. There's a link here in the screen now shown, so please do open that as well if you're going to run through this process. Step one in the procedure is installing Ondat. So Ondat Snapshots were introduced in version 2.08. If you're installing Ondat for the first time, follow the instructions. They're documented, and again, the link is here. If you're upgrading the existing Ondat deployment, then please follow these instructions. Again, these are available in the screen here. As we can see here, I'm logged into my Ondat portal. I have a connected cluster sat here. If I go and jump onto my cluster here, we can see we have effectively our storage OS pods up and running, and our Ondat cluster is ready now and available within here. So the next step here, we're going to jump onto the CloudCasa site and we're going to go to the login and sign up option. If I click on that, that's going to log me into the CloudCasa dashboard. If you haven't got an account within here, you can also obviously select sign up, run through the sign up process. We have a free tier available, a starter tier, that allows you to utilize the functionality of CloudCasa for testing purposes and store up to 100 gig of data in there as well. So please do take advantage of that, sign up, and you can get started with CloudCasa. So once we're logged in, we are going to effectively add our cluster within here. So if we jump into protection, clusters overview, and if we select the add cluster option in here, if we input our cluster name, input a description, and also within here, we can select some advanced options if wanted. We can add tags. We can add a private container registry. We can also alter the default backup destination for the cluster. By default, that's going to use the global default, which is configured with under configuration and all the storage settings within here. If you want to utilize an alternate setting to the global default, if we select CloudCasa storage, we can go down here and select the available CloudCasa storage in AWS and Azure. Or if you've set up your own S3 buckets and want to utilize your own storage in here, you can select My Storage and utilize that. For the purpose of the demo, we'll use the global default. So if I click Save here, what that's going to do is it is going to return a YAML file in here that is going to contain effectively the command that we need to run within our terminal on our cluster, kubectl command. That's going to go out, that's going to install the CloudCasa agent. It's going to enable connectivity back into CloudCasa via gRPC over port 443. Once that's done within here, then effectively it's going to perform an inventory, and we're going to have the ability then to start defining backups of this cluster. So we copy the kubectl apply command within here, jump into our cluster, come here, run that. We can see in here now the service account, the cluster binding RBAC and the deployment.apps manager in there have been effectively created. If we run within here now as well, so we can see in here now we have a namespace of CloudCasa-IO, and we also have a pod up and running in here for the Kube agent manager as well, and that container was created at this point in time. And now that's in the running state. So if we jump back into the CloudCasa portal, we on our cluster in here, so we can see the cluster's now marked as registered. That'll just be running through the inventory process in here. And then once that's successfully inventorized that, which will just take a moment or two, effectively within here, then we'll start being able to define backups. So we can see now in here, the cluster is marked as active, the inventory's run within there, and we've now got the ability in here to start defining backups. So by default with CloudCasa, we provide the required Kubernetes snapshot CRDs. However, in order to use the Kubernetes snapshot feature, snapshot controller must be installed. The snapshot controller monitors the Kubernetes API server for volume snapshot and volume snapshot content CRDs and forwards the necessary requests to the Ondat CSI plugin. So there's a couple of commands I'm going to run here that are effectively going to install the Kubernetes snapshot controller that required. Those commands are available again in the quick start guide, so please do get them from there. So we've now got our Ondat cluster up and running. We've got our CloudCasa account set up. We've added our cluster into CloudCasa. That's now connected within here with the agent up and running. So effectively already start running a backup and recovery function walkthrough. So here I'm going to create an example deployment. I'm going to create a new namespace called Ondat and CloudCasa test, and that's going to utilize an Ondat PVC. So we create the namespace. So then I'm going to run a .yaml file. This is going to create a deployment. It's going to create a pod with 2 containers and a PVC. The date container is simply going to append the date SDT out and MNT date every 5 seconds within here. So we need to run a kubectl get pods -a to get the pod name. So we can then see in here what we're doing, obviously, is to SDT out MNT date every 5 seconds. We're seeing an update in here with a timestamp within here. So there we go. That's continuously updating at this point in time. The sidecar container here simply mounts in the PVC under MNT and then lies dormant. This container will be used during the snapshot process to quiesce the file system so a consistent snapshot can be taken. It serves no other purpose. Notice how this container must have the privilege flag set to true though, and this is necessary if you want to run the fsfreeze command to ensure application consistency for your apps whilst running backups. So next what I'm going to go and do is set up a backup policy. So in CloudCasa, if we jump into configuration, protection, policies, and select add policy, then input the required information, which is the policy name, the time zone within here. Set how frequently you want the policy to run. So we set it to run every day at midday. Set the retention period you want within here to set. So by default, we set that to 30 days. That can be increased and decreased as you wish. Also within here, you can enable safe lock. What safe lock does is it locks the snapshots and copies that are kept via CloudCasa, ensure that they cannot be removed. They cannot be removed by any user, and it adds an additional level of protection against the likes of ransomware or any form of user coming in attempting to maliciously delete your data within here. Data cannot be deleted if safe lock is enabled. Once done, if we click add to schedule in here, we're going to see that schedule added in within here, and if we click create policy, that policy will then be created. So we can see in here, there is our policy. So in order to utilize the Ondat CSI plugin with the Kubernetes snapshot feature, you must provide a volume snapshot class for the Ondat CSI plugin. Once the snapshot controller has been installed, you need to edit your storage OS cluster. We're going to do that via the following kubectl command. So if we run kubectl -n storage OS edit storage OS clusters.storageos.com storage OS cluster. What that'll do is it'll open our configuration, and we can see in here now we've got our configuration open. So what we need to do within here is we need to add the volume snapshot class name line under snapshots as per the following. So you can see here that has been added. If we select save, that will then be saved within here. If we exit the file, we can see in here our storage OS cluster.storageos.com has been edited successfully. So this will prompt the Ondat operator to create a volume snapshot class named CloudCasa-CSI-StorageOS-com, and it's going to configure it for use with CloudCasa. You can get the volume snapshot class by running kubectl get volume snapshot classes. So you can see in here our volume snapshot class has been successfully created. Next, what we're going to do is we're going to define and run a backup. So you can do this in multiple places within the CloudCasa. You can do this via the dashboard, going to define backup within here, or you can go into protection, clusters. You can find your cluster within here, and you can select define backup within here as well. So we're going to provide our backup with a name within here. select the cluster that you want to protect. If you want to add any tags in here as well, that can be done. We've got the option here of backing up the full cluster or specifically selecting namespaces within here. For the purpose of the demo, I'll do the full cluster. We can also select labels if wanted. By default, we're going to include persistent volumes. If you want to only back up resource metadata, obviously uncheck that. That's only then going to protect the resource metadata, not your persistent volumes. We can enable app hooks. So if you want to run any pre and post scripts, if you want to run FS freeze, for example, you can enable that via here. Tick that. That'll take you onto another page in terms of defining pre and post scripts. You can manually utilize your own, or you can utilize the templates that we have available in CloudCasa for selected applications such as MySQL and Mongo. Within here, then select if you want to run a local snapshot only, or if you want to run a snapshot and copy. For the purpose of the demo, I'll do a snapshot and copy. If you want to also delete the local snapshot after the copy, that can be done here via CloudCasa rather than having to do that yourself manually. And again, in the advanced options, we have the destination storage for the copy, which by default we're going to inherit from the cluster preferences. But if you want to alter that again within here, change the storage that you're going to utilize, you can select CloudCasa storage in here, select the available AWS or Azure storage that we make available to yourselves, or you can utilize your own storage again if you've registered any of your own S3 buckets. By default, we're going to use 2 concurrent streams per persistent volume. If you want to increase or decrease that, that's fully possible. Also, in terms of the max speed per stream, if you want to enable throttling here in megabytes per second, then that's possible within CloudCasa. So you can see here our policy that we've defined is available here in terms of the Ondat demo, so we'll utilize that one there. And within here now, if we select create, that is effectively going to define our backup. So there we go. Now we've got our cluster. We can see the backup that's defined in here. I'm going to run that now. So when we select run now, we can select an alternate retention policy. So if I put that down here to 3 days, and that successfully started our backup job. So if you click on the in progress option here, you can see here we can click on the job itself and we can see an overview of what's happening in terms of the information. We can look into the activity log, see where we are in terms of the backup at this point in time. We can also see the persistent volume details for the snapshot, which is completed. And we can also see the persistent volume details for the copy, which will start shortly. So we can see in here now the persistent volume details for the snapshot, the CSI snapshots for the MyPPC and Storage OS etcd 0 have completed. Also, we go into the persistent volume details for the copy. Again, the copies have both completed as well within here. So we select OK on there. Jobs completed, not running. And as we see, that's successfully completed within there. So if we jump back into our cluster within here, we can see here we've continued to append to that file within here. So you can see that's continuing to update regularly within here every 5 seconds. So what we're going to do now is we're going to set up a disaster recovery scenario. We're going to delete our dummy application and the associated namespace within here. So we can see in here our deployment.apps, my app deployment has been deleted, and also the Ondat and CloudCasa test namespace has now been deleted. So this is where CloudCasa comes to the rescue. We're effectively now going to run a recovery of that backup that we just took. So again, we can get to define restore from multiple places. If we jump into protection, clusters, we go to define restore on the cluster, and this is where we'll define our restore. We can see in here the available recovery points. So we can see we've got a copy available that we just took of the specific cluster here. We select next. We've then got options in terms of the recoverability and what we want to do. So we can recover all protected namespaces. In this specific example, I'm only going to recover the Ondat and CloudCasa test namespace because obviously that's the one that's been impacted by our disaster recovery scenario. Within here as well, we can select labels. We can also just restore specific resource types if you want to drill down and only do specific resource types. We can also, again, enable app hooks to run pre and post scripts here for your recovery. We can, again, exclude persistent volumes if you want to within here. So if you just want to bring back resource metadata, but with this, we'll bring back the persistent volume associated within this namespace as well within the demo. So I'll give my restore a name. Within here, we can select a destination. We can go back to the original cluster. If we want to go back to an alternate cluster, we can. We can also rename namespaces within here. If you want to add a specific prefix and suffix, that's possible. Also, if you want to change the storage classes within here as well, again, that's fully possible and very useful for migration purposes. However, if we select restore here, what that'll do is it'll start our recovery process for the Ondat and CloudCasa test namespace. So if we look into the activity details here, see the activity log, see the recovery process is starting, the resource is now restoring. We can see there the restore has been successful. So if we jump back into our cluster, confirm the application is back up and running. You can see here our app is now back up. It's been up for 48 seconds. So within the cluster, if we look at the file, we're appending the date and time into every 5 seconds. So we can see in here now that is back up and available. There is obviously a small gap here in terms of the timestamp from when the backup was taken to when then the recovery is run. And now again, that is being appended to again within here. So a small gap in there as expected, but now back up and running, data's back accessible. CloudCasa saved the day alongside Ondat Snapshots. So that's done. That's really all there is to it. It's very simple. Sit back and relax, knowing that you can take an ad hoc or schedule backup and complete restores of your Kubernetes cluster's resources, system volumes, and cloud native applications. Thanks for joining me on this demonstration video today. If you've still got any questions about CloudCasa, feel free to get in touch with us via casa@cloudcasa.io.